Okay, I'm going to try to attempt with my fancy new pen to go over this problem. That's not what I wanted to do. I'm really sorry. You're going to have to bear with me just a little bit as I figure it out, but that's just how it goes. So let's write with blue. Okay, first, maybe I can do this. All right, so I'm going to keep going back and forth between the picture and the questions. So first compute, so g of x equals the integral from 1 to x of f of t. So compute g of 4 and compute g of negative 2. I'm going to put this answer up here. All right, why does it keep looking like that? Whatever. Okay, so if I'm going to compute g of 4, that is going to be the integral from 1 to 4 of f of t dt. So I'm going to go over here and I'm going to say, okay, what is the integral from 1 to 4? So I'm going to be putting together the area under here and the area under here, and then also the area here. Well, I see that the area above and below here are going to cancel each other out, so I don't even have to worry about taking those areas of those two parts. I just have to worry about the trapezoid. So the trapezoid is going to be 1/2 times the bases added up times the height. The bases added up are 4 and 1, and the height is just 1. So I get in the end 5/2. Now I need to answer what is g of negative 2. G of negative 2 is saying what is the integral from 1 to negative 2. So now I'm going to be going backwards. So from 1 to negative 2, because I'm heading in the opposite direction that I normally do, the opposite direction that we read. And the area above the x-axis is going to be negative. So that area is going to be the area of the triangle. But the area of a triangle, and then I'm going to be negative. So negative 1/2 times base times height. So the base is 1, 2, 3. The height is 4. So I'm going to get negative 6. All right. Easy, no problem. And this basically, yeah, so we haven't really talked about Leibniz Law yet, but here we go. Part B. Find the instantaneous rate of change of g with respect to x at x equals 1. So the instantaneous rate of change of g means find g prime. Well, if g of x equals the integral from 1 to x, g prime of x is asking us to take the derivative of that integral. To take the derivative of this integral, this is Leibniz Law. It says plug x in for my variable and multiply by the derivative of that upper limit, which is just 1, minus plug in the lower variable and multiply by the derivative of that variable, which is 0. So in the end, g prime of x just equals f of x. So g prime of 1 equals f of 1. And this is the, what am I looking at? This is the graph of f up here, right? So what is f of 1? F of 1 is equal to 4. So g prime of 1 equals f of 1, which equals 4. Sorry, I ran out of room. Okay, there's A and B. Now, I'm going to go down here, find the absolute minimum value of g on the closed interval negative 2 to 4 and justify your answer. Okay, so if this is, I'm going to do part C over here. So if they want me to find the absolute min, I need to figure out where my critical values are, and I need to test the critical values and the endpoints. So let's first see where our critical values are. And let's remember that our critical values for G are going to be when G prime equals 0 or is undefined. And G prime is the same. Let's see, and we're looking for a minimum. So we have to actually figure out when does G prime we're really looking for when does G prime change from negative to positive. That's where I know I'm going to have a min, from decreasing to when G changed from decreasing to increasing. So if G prime is the same as F, right? We know that G prime is the same as F. Let me go up and look at the picture and figure out what critical values do I have between -2 and 4. When does the derivative change from negative to positive between -2 and 4? So up here, between -2 and 4, it looks like that never happens. We change from positive to negative at 3. So G will have a max at 3, but not a min. So therefore, I'm going to be looking at a table of values. And I don't even have to include 3. 3 is a critical value. So if you want to put 3 on here, we can, but there's really no need. I just need to test the left endpoint and the right endpoint. And I'll include in my justification that x equals 3 doesn't count. So at -4 and at 2, I think we already have those values, right? We have G of -2 is -6. And we have G of 4 is 5/2. So the question asks, find the absolute min. So the absolute min is -6. Remember, it's the y value, not the x value. Because blah, 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 blah. I don't feel like writing this all with my pen, but because the only critical value on the interval -2 to 4 is at x equals 3, but you would have a maximum there. So the only places that a minimum could exist are my 2 endpoints. And when I look at the y values of the endpoints, the y value at x equals -2 gives me the smallest y, so that is my absolute min. Okay, part D. The second derivative of G is not defined at x equals 1 and x equals 2. How many of these values are x coordinates of points of inflection on the graph of G? Justify your answer. Okay, so how do we know if something's a point of inflection? I need to figure out, when does the second derivative of G change sign? Or when does G prime change from increasing to decreasing, or vice versa? So let's go up. Well, G prime is the same as F, right? So the graph up above is the same thing as G prime. So does G prime ever change from increasing to decreasing? Yeah, right here. So G prime changes from increasing to decreasing here at 1, not here. Yeah, I have a sharp turn, but I decrease the whole time. So this happens at x equals 1, which is therefore my point of inflection. Yay, there's the problem.